One sensor, 2 datasets, and 0 equipment headaches. Whether you just need to quickly jot down ambient conditions, or you're looking for patterns in data that uncover the relationship between pressure, temperature, and other variables, PASCO's wireless absolute pressure temperature sensor makes studying gases a breeze. Let's get started. The wireless absolute pressure temperature sensor is rechargeable, and it comes with a charging cable, a fast response temperature probe that plugs into the temperature port, tubing and fittings that attach to the pressure port for studying gases in closed systems, and a syringe that connects directly to the threaded pressure port with a hand-tight fit. When you turn on the sensor, its default measurements report pressure in kilopascals and temperature in degrees Celsius. But let's say I want to see temperature in kelvins. Change the units for either measurement by double-clicking the power button, then single-clicking your way through the measurements until you see the measurement with the unit you want. Just stop clicking and wait for the display to return with your new unit. So if temperature goes to kelvins on the display. If I change my mind, I could have double-clicked to cancel the unit change. So ambient conditions today at PASCO headquarters are about 101 kilopascals and 298 kelvins. You can long press the power button to turn the sensor off or leave it on, and it will turn off by itself after 1 hour. As we've seen, you can use the sensor independently, or you can connect it to PASCO software like SparkView, Capstone, or ChemView. I've already connected to SparkView via Bluetooth. I'll select both temperature and pressure measurements, and I'll choose a graph display. Once you connect to software, the sensor can record and display data like other wireless sensors, so you can experience the data visualization and analysis of your choice. And if you forgot to charge the sensor, you can connect it to SparkView with the USB cable. Or if you want to only use the display, you can plug it into a USB wall charger. How do you think the temperature and pressure of the air trapped in this closed system will respond when I set this bag of salty ice water on top of it? Let's use the sensor to find out. I'll tape the temperature probe to the sensor box. So the thickened part at the end of the probe, where temperature is measured, only touches air. Let's start collecting data to get the baseline conditions for comparison. Okay, now I'll set the bag on top. And look at that! Did you see how adding weight to the container made pressure spike? Think about why that happened. We'll speed through the first minute of data collection for you. So the graph shows that the closed system is cooling down because temperature is decreasing. And as temperature drops, so does pressure since the container size is fixed. So this is a quick qualitative visual demonstration of how temperature and pressure vary directly with one another when system volume and moles of gas are held constant. If I want to turn this activity into a quantitative investigation, I can use the available absolute zero sphere, which has a stainless steel bulb that can withstand temperature changes without a significant change in system volume. Or I can use the available ideal gas law apparatus to study the relationship among pressure and temperature when volume is changed. Or you can do a simple Boyle's law or pressure volume investigation with the included syringe as a closed system. Visit the product page linked in the description to learn more about the wireless absolute pressure temperature sensor and its compatible accessories, including specifications and links to lab investigations. Thanks for watching!